Hey guys, this is Mr. Mitchell. Today we're going to be talking about Lewis dot diagrams. So first of all, what are Lewis dot diagrams? Lewis dot diagrams are just really simple ways to help us visually display the valence electrons that an atom has. So over here we have examples for carbon and for fluorine. So carbon, if we remember, he's got 4 valence electrons, so we got 4 dots around him. It shows he's got 4 valence electrons. Fluorine has 7. He's got 7 dots around him. It shows us he's got 7 valence electrons. And so it's just a quick way for us to see how many valence electrons that different elements have. So just to refresh our memories, if we haven't done this enough so far, what we want to remember is that the columns of the periodic table are what tell us how many valence electrons an atom has. So if we're in the first column, these guys have 1 valence electron. These guys in the column 2 have 2 electrons. These have 3, 4, 5, 6, 7, and 8. So we always skip the middle section when we're counting those up, but we always want to go back to this idea that the columns are telling us how many valence electrons each element has. So how do we draw this dot diagram? First, we use the periodic table to determine how many valence electrons each element has. Then we're going to start on one side of the element's symbol and we're going to draw a single dot. And then we're going to move clockwise around the symbol and continue distributing dots one at a time, almost like you're dealing cards, until you've reached the total number of valence electrons. So that card example I really like. It's one that a student came up with. When you're dealing a deck of cards, you don't say, all right, here's 7 to you, and 7 to you, and 7 to you. You go 1, 1, 1, 2, 2, 2, 3, 3, 3. We do the same thing with the electrons when we're drawing dot structures. So let's do a couple examples real quick. We're going to draw dot diagrams for the following elements. We got potassium, phosphorus, and bromine. So we'll start with potassium. If we go back to the periodic table, we see that potassium is over here. He's in the first column, so we know that he's going to have 1 valence electron. So when we want to draw our dot diagram, we only need to do 1 dot. We can start at the top, on the left, on the right, or the bottom. We're going to start at the top just because that's what I want to do. So we draw a single dot at the top, and we're done. He has 1 valence electron. We have 1 dot there. Okay, let's move on to phosphorus. Phosphorus, if you went back to the periodic table, you see he's in the 5th column. Okay, so we're going to pick a side. I'm just going to pick the top again because I just feel like it. And we'll start with our single electron up top, and then we move around clockwise and we distribute each dot to each side. So we start with 1, we go to the next one, that's 2, here's 3, 4, and remember that phosphorus has 5, so when we come back here, now this top section is going to get 2 dots. Okay. One big thing that I like to point out is that it's almost as though there's a box surrounding the symbol, okay, and each side of that box can have a maximum of 2 dots on it, okay. So you're not actually going to draw the box when you do the dot symbols, but know that each side of that box is going to have at most 2 dots around it. So phosphorus has 5 dots for his 5 valence electrons. Bromine's our last one. Bromine's in the 7th column actually, and so we'll do the same process over again, except we need 7 dots this time. So we'll start at the top, do 1 here, all right, then we go to the next side, 1 here, that's 2, 3, 4, back up top, 5, 6, and 7. So that's our dot symbol for bromine. So what are these things used for? Dot diagrams are actually very helpful in determining whether or how many bonds different elements can make. And so the amount of potential bonds that these elements can make is going to be the same as how many unpaired electrons are around the diagram. So for example, fluorine down here, here's a pair of electrons, here's a pair of electrons, here's a pair of electrons. Those guys are all paired up, so no bonds are going to happen there. But I have 1 electron that's by itself, and so fluorine can form 1 bond because he's got that 1 electron. Carbon has a whole slew of electrons that aren't paired up, so he can make a bond here, he can make a bond here, he can make a bond here, he can make a bond here. So carbon can actually make 4 bonds because he's got 4 unpaired electrons surrounding him. So very simple rule. Let's go ahead and practice that one. Let's determine how many bonds each of these elements can make. So I have sulfur. Sulfur is in the 6th column, So he's going to have 6 valence electrons. So we start at the top again. 1, 2, 3, 4, 5, 6. And so if I want to figure out how many bonds he's going to make, I got to look for the unpaired electrons. Well, here's one and here's one. So sulfur can make 2 bonds. Let's go to neon. Neon is actually in the 8th column. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. And now we're going to look for how many bonds he can make. Well, are there any unpaired here? No. These are paired, these are paired, these are paired, these are paired. So neon actually can't make any bonds. He's got 0 bonds. Our last one is chlorine. Chlorine's actually in the 7th column. So we're going to go with 7 electrons here. 1, 2, 3, 4, 5, 6, and 7. So how many unpaired electrons do we see here? Chlorine actually only has 1 unpaired electron, so he can only make 1 bond. So that's all we're really going to do for dot diagrams. They're fairly simple, but again, they're very helpful in determining or visualizing how many valence electrons the things have and how many bonds these different elements or atoms have the potential to make with other atoms.